Okay, so this is the review, chapter 5, number 6. So I have a polynomial. F of x is equal to x to the fourth plus 2x cubed minus 13x squared minus 38x minus 24. And I am told in the problem, see, we can find the solution to linear equations pretty easily. We can find the zeros to linears pretty easy, right? And we can find the zeros to quadratics pretty easy. We can either FOIL it, or we can use the quadratic formula, or we can complete the square. So those are all ways that we can find for quadratics. But once we get above quadratics, and we get into equations that have a power of 3 or 4 or 5, it's not so easy to solve them. In fact, I'm just reading this book. I'm sure I've mentioned this book. I'm reading this book on the history of algebra, and it took them like 150 years to be able to figure out how to, after they figured out how to solve the quadratic, to how to figure out the cubic. And then there's actually a formula that you can use to solve for the zeros of a quartic, right? A fourth power equation. But if I gave you that formula, you would vomit, because it's really gross looking, right? It's nasty. So what we want to do is we're going to do it a different way. And we are given in this problem that we're given two zeros. We're given that one of the zeros is minus 3 and another zero is minus 1. So they're telling us this, which is very nice of them. So what I need to do is I need to use the fact that I know those two zeros and to press this equation into a quadratic. Because how many zeros am I going to have in this equation? Anybody have an idea? The most number of zeros I could possibly have in this equation. Anybody know? 4. It's the power of 4. It's the most I can possibly have. They're giving me 2. If I can figure out a way to use those 2 to reduce this equation, I'm only going to be left with 2 left. That's a quadratic equation. I can do that. So what I need to do to solve this is I need to work with these zeros and to press this equation, and I'm going to do that by using synthetic division. So my coefficients here are 1, 2, minus 13, minus 38, and minus 24. And I'm going to use synthetic division with one of my factors there to find out, to depress the equation one level. And since I'm like to take the easy way, I'm going to use minus 1 as the factor that I'm going to use synthetic division by. So I use synthetic division. My first coefficient, I just drop down to the bottom. I don't make any changes on that one. And now I start multiplying by my 0. So negative 1 times 1 is negative 1. And unlike regular division, I don't subtract, I add. I have to add these things. So 2 plus negative 1 gives me a positive 1. Well, negative 1 times 1 gives me negative 1 again. I add these two together, I'm going to get negative 14. Negative 1 times negative 14 gives me positive 14. I'm going to add these two together. I'm going to get, that'll be negative 24. And when I multiply negative 1 times negative 24, I get positive 24. And when I add those two together, I get 0. So when you are doing synthetic division of a polynomial with one of the zeros, you have to end up with 0 as your remainder. If you don't end up with 0 as your remainder, then you either made a mistake or I made a mistake. Right? If I tell you it's a 0, you're going to end up with 0 as a remainder. If you're just kind of testing it out to see if it's a 0, then you might not end up with 0 as a remainder. But when you end up with 0 as a remainder, that is a 0 then of that equation. Okay. So, I started out with x to the fourth, third, second, first, and my constant. I've now taken out one power. My 0 of -1. Taking out one power. So really, and I do this in little pencil here, you know, x to the third. Now I'm at x to the third, x squared, x, and then my constant. I have another 0 I can work with, -3. You see why I use -1 first? I have more to do with it. Easier to work with -1 than -3. Not that big. I need to now use -3 to reduce this even further. The mistake that is very common here is saying, well, I have a factor of -1, I have a factor of -3, and applying them both to the original polynomial. You don't want to do that. You want to first depress it one level, and then you want to depress it another level so that we can get to a quadratic, to a highest power of x squared. So don't just do the -3 into the same coefficients that you did before, because then you're not depressing. You're just going to have two different a third level expressions. It's not going to help you very much. So I'm doing it again now. So I'm going to bring down my 1. -3 times 1 is -3. I'm going to add those together. That should give me -2. -3 times -2 is +6. I'm going to add these together. I should get -8. -3 times -8 is +24. And we're very happy because we have a 0 there as our remainder. So now what I'm left with is, this is my x squared. That's my x. And that's my constant. So if I was to write this now, let's see, the question asks for, given the two zeros, find the remaining zeros. So if I was to write this now, this would look like x plus 1 times x plus 3. Let's make it a little nicer. Times x squared minus 2x minus 8. This gives me a factor of x equals -1. This gives me a factor of x equals -3. And now I'm left with a quadratic. So if I want to find my two remaining zeros, I need to factor my quadratic. And I'm looking at that, and I can FOIL that into x minus 4, x plus 2. So now I have this totally factored out polynomial. My zeros are -1, -3, which I was given, 4, and -2. Those are the values of x that will give me 0 for this polynomial. Are there any questions on this one? Yeah. Yes,
does it matter if you do the -3 first and then the -1?
It matters not. It doesn't matter if you do the -3 first or the -1 first. You'll come out with the same answer. Just make sure that when you do the first one, you do the second one on your depressed equation. Okay? Don't do it on the original equation. We're in the business of depressing equations. All right, so I'm going to